People hate autocorrect, but if it wasn't for autocorrect, my messages would sound like hieroglyphics, or it would sound like monkey was the one typing that message. I feel like you don't need more than just 100 words per minute. Like, honestly, like if you could type faster than 100 words per minute, I mean, good for you. But personally, for me, I found that like typing beyond 100 words per minute, it's kind of useless. Like, at least for me. Using AI to create the perfect keyboard. This is going to be pretty interesting, okay? Because you guys already know I love typing. Sometimes I'll type and I'll post it here on my channel. I love typing. I could type 100 words per minute, over 100 words per minute, but I usually average around 98, 96. That's like my average. And the only reason why I even average that is because my accuracy is horrendous. I have terrible accuracy. So once you have passed 100 words per minute, like it's pretty much, it's no longer about how fast you could type on it. Rather, it's about how accurate you are. And I am very inaccurate when it comes to typing above 100 words per minute. And then, of course, I do want to mention as well that there are many different types of layouts, but the QWERTY keyboard is probably the most common. There's all sorts of different types. So it's called QWERTY because of the first letters. Are you serious? That one, because of the first letters right here, QWERTY. That's the reason why this layout is named the QWERTY keyboard layout. And then there's also the Dvorak keyboard, which I have not mastered. This one is, instead of having the QWERTY up here, it has AOEUI. So the left hand, since most people are right-handed, the left hand doesn't really move too much. It just positions itself on the vowels, while the right hand, which is very flexible when it comes to your phalanges, it's able to move across the entire keyboard here at ease. So there's many different types of layouts. Those are the two common ones I know, but there's many of them. But nonetheless, it turns out that the AI that they're about to present here has made a perfect keyboard, which I'm very curious to see what it's gonna look like. Let's go ahead and watch it.
Most of the English-speaking world will be familiar with this keyboard layout. Named after the first 6 letters on the top row, the QWERTY keyboard was invented for typewriters nearly 150 years ago by Christopher Latham Scholes and has remained unchanged ever since. Technological innovation in the past 150 years has soared, but
that is insane. Look at that. This is ancient. And then this is what it is now. What a difference, the technological differences. Imagine if like someone in the past, back in 1878, was to see a layout like this. That'd be pretty insane.
Keyboard layout has remained a constant. It just hasn't made sense to change a design that so many people are already familiar with, despite how unintuitive the layout may be.
And one more thing, before the typewriters changed to the QWERTY layout, it used to be A, B, C, D, E, F, G. It used to have the rows in alphabetical order, but they realized that it was a lot more difficult to actually reach the letters, because when you go down the keyboard, it's actually a lot harder to type down. So, that's why when you type, most times what you're doing is you're typing these letters here, but you're also typing these letters, because most of the words exist within these realms right here, mostly in the middle here, but it would exist within these realms. Now, of course, you still have the M and M, but like most words are done using these top keyboards. But at least that's what I think. I may be wrong in that. If I'm wrong, please correct me in the comment section below. Yeah, so if my memory serves me correct, then that's why it's laid out the way it is.
But I wanted to know, how much better can the keyboard actually be? In the context of this video, a good keyboard is one that is efficient by minimizing the total distance the fingers have to move when typing. Assuming you use all 10 fingers to type, your fingers should start in this basic position. Each finger is responsible for typing specific keys on the keyboard. For the purposes of this video, we will only focus on the letter and punctuation keys. By following these rules, we can calculate how far each finger has to travel for any given letter pairing. If we assume that the distance from one key to the key left or right of it is 1, then the distance from a key in the middle row to a key in the top row is approximately 1.032. Notice that the bottom row is slightly more offset than the top row, which means that the distance to the bottom row will be slightly further at approximately 1.118. This is common among many keyboards, but not all keyboards, so your keyboard might look slightly different. The distance from the top row to the bottom row is about 2.138. This covers most key pairings, but there are special cases for fingers 4 and 7 since they are responsible for more keys. Using all of these distances, we can calculate the total distance the fingers will travel in order to type any given word. For example, in order to type the word have, finger 7 moves from J to H. Finger 1 doesn't need to move anywhere to type A. Finger 4 moves from F to V, and finger 3 moves from D to E.
Okay, so just in case you guys don't know what's going on, so he's pretty much just calculating how fast your finger will move across the key, how fast it will move from one letter to another. And I assume that he's probably using the average speed. The average speed is usually 40 to 45. So it'll probably take about like a second to get to the other letter. But somebody like with like my speed, it's much lower than this. You know, so I'll show you guys. So, you know, like, you know, that like that, it doesn't even take a second for me to like type all of that. Like, it's usually like people who are really fast. I could show you what that looks like. Let me go ahead and reset that. So the average speed is 45. So if you take a look at the bar that's going across, we'll see, watch. You see this bar right here? That's how fast the average person types. It's that slow. And if I show you, see, compared to me, if I stop missing, you know, so I'm pretty fast. It doesn't take me even a second to like finish a word. So that's the fastest typing speed. So I assume that he's probably using that speed to make these numbers. So yeah, see, so 45. Anyways, let's go.
This gives a total distance traveled of approximately 3.15. It's worth noting that for words where a letter appears twice in a row, your finger doesn't need to move back to that letter. So to type a word like pool would be a distance of 3.096. In order to create the most optimized keyboard for efficiency, I'll be using a genetic algorithm. If you're not familiar with genetic algorithms, then I'll explain it in the context of this project. As I already mentioned, for a given keyboard layout, we can calculate the total distance it will take to type something. For example, using the QWERTY layout to type "the quick brown fox jumps over the lazy dog," will have a total distance of about 34.611. Then we could take another keyboard layout, like the Dvorak layout for example, and calculate the total distance for the same sentence, which would be just 22.823. Since we decided that the most efficient keyboard is one that minimizes distance, then we would conclude that the Dvorak layout is a better and more efficient keyboard layout than the QWERTY layout. However, this would be a really bad test since it would just be testing the distance over one sentence. Instead, we should calculate the distance over a very large dataset of text. For this video, I use the archive.org abstract dataset. Archive.org is an open access archive for research papers and other scholarly articles. And on the site, each of these articles has a short abstract that describes the paper. I used the archive.org dataset to create a large collection of these abstracts. What I was left with was a textual dataset of about 37,000 English words and 240,000 total characters that I could use to better test the efficiency of a keyboard layout. For example, when I simulated typing this dataset using the QWERTY layout, the total distance was about 174,000. Compare that again to the Dvorak layout, which had a total distance of only 96,000. Now we can more confidently conclude that the Dvorak layout is in fact more efficient than the QWERTY layout.
Okay, so essentially here what he's talking about is just how fast each layout is. And of course, as I showed you, the Dvorak keyboard is a lot faster because, again, your left hand, you don't really have that much control of your left hand. So you want to keep your left hand like just stagnant here. Just move side to side, and it's just as simple as that. While the right hand, because it's your dominant one, you have more control, more dexterity with this hand, so it's able to move up and down, while the left hand just kind of stays in the middle. So it looks like this. So that's why the Volrak, God, I can't pronounce that word. The Volrak keyboard is so much faster. And so the reason why you see this so much higher is because this is how long it takes. It's talking about, I assume that this is the speed. I don't know what 150K is, but just know that the reason why, the fact that this is higher, it means that it's slower. Just kind of want to showcase that and let you know that just because it's a lot larger here or a lot taller doesn't mean that it's faster. Like, this is, if anything, it's the opposite. The fact that it's a lot taller means that it's a lot slower. The Volrak is a lot faster. So hopefully I didn't confuse you guys.
Now, instead of using two predefined layouts, let's use a bunch of randomly generated keyboard layouts and calculate the total distance for each. In genetic algorithm terms, each key on the keyboard would be a gene, each keyboard itself would be referred to as a chromosome, and all of the keyboards together would be referred to as our population, and our population size would be 10. The total distance for each keyboard would be referred to as its fitness score. After we've calculated the distances for each keyboard, we can take the most efficient keyboards and use them to create new layouts. We can create a new keyboard layout by combining any two of these keyboards together. We choose a point at which we will split the keyboards and then add the keys from the left of the split point from keyboard 1. We could add the keys from the right of the split point from keyboard 2, however, this will usually create an issue where there are duplicate keys. So instead of adding all the keys from keyboard 2, we only add the remaining keys that are needed in the order that they appear after the split point. The hope is that by doing this, we can potentially create a better keyboard by taking good traits from both of the keyboards and combining it into one. We will then repeat this 10 times, choosing random keyboards and split points each time to create 10 new keyboards. This will be the population for the next generation, and the entire process will be repeated again. By only using the most efficient keyboards from each generation to create the next generation, the keyboards should become increasingly efficient over time. This process mimics natural selection. Only the best keyboards survive, and they are used to create the next generation of keyboards.
Man.
I implemented the genetic algorithm in Python and ran the algorithm for 1000 generations with a population size of 150. The first graph shows the distance for the most efficient keyboard in the entire generation. The second graph shows the average distance across the entire population for each generation. The keyboard layout shown is the most efficient layout that the genetic algorithm has found so far. You can see that the genetic algorithm makes very quick progress at the start, finding a keyboard with a total distance under 80,000 within the first 30 generations. After this, the progress becomes much slower. It isn't until generation 109 when the distance drops below 75,000. After another 100 generations, the total distance for the best keyboard found is just about 74,000. For context, remember that the total distance of the QWERTY keyboard was 174,000. It isn't until generation 279 that the next and final improvement is made to the layout. The algorithm runs for the total 1000 generations, but doesn't make any additional improvements.
I'm not gonna lie, this thing is so hard to understand. I really don't understand what's going on, but I'm trying my best to understand it, but he lost me. I'm trying my best to understand it, but damn. All I know fundamentally is that there's generations of keyboards are being generated, and the best ones are being kept around while the rest of them are just purged. I hope that makes hopefully that's I'm following this so far.
This is the best keyboard that was generated by the genetic algorithm. I also ran the algorithm 2 more times, this time with a population size of 200, and got similar but slightly different results. The total distances for all the keyboards was in the low 74,000s. This is about a 57% decrease from using the standard QWERTY layout. We can see some similarities among all of the keyboards. For one, the semicolon and question mark keys are in the middle of the keyboard. This makes sense because the position of these keys are further from the starting keys than any other keys. Since the question mark and semicolon are less frequently used than any other keys, it makes sense to have them in the furthest away positions. Another similarity is that all of the vowels except U are on the middle row, as well as the consonants R, S, T, L, N. This makes sense because these are the most frequently used letters, so it makes sense to have them be the starting keys. If you've ever watched Wheel of Fortune, then you'll know that in the bonus round, the show gives contestants the letters R, S, T, L, N, E because they are commonly used letters. As a tribute to that show, I'll be referring to this style of keyboard layout as the R, S, T, L, N, E layout, since all of these letters feature on the home row of these keyboards. If I were to...
That's pretty interesting. I can see why that would be an effective... Yeah, so let me take a look at the QWERTY keyboard really quick. Images. This one. Okay, so yeah, most of those letters should be up here, like around here, like between these two rows. Like I said, like they're supposed to stay up here because these are, your fingers are easy. It's a lot easier for your fingers to go up rather than to go down. When you go down, it kind of just like squeezes the space. So R, T, S, L, and N, right? Was the other one? N, E. E is right here, but N is right there. So yeah, I know N is frequently used, but J, that one's, it's not too hard. The hard ones for me is X, C, and Z. Those are really difficult for me to reach. So sometimes when like words with like X will show up, sometimes I'll hit X. Sometimes I hit C when I meant to hit X, and then sometimes I'll hit X when I meant to hit Z. Yeah. Pretty hard.
To suggest a keyboard design that implements the RST-LNE layout, it would look something like this. It minimizes the changes that need to be made to the QWERTY layout, making it easier to learn, while also keeping the key features of the RST-LNE layout.
Yeah, so D is no longer here. J would be here, right? No, F. J, K, L, and then the semicolon. Interesting. W, D. What an interesting layout. I don't know
This
how
design has a total distance of about 80,000 on the dataset, making it slightly less inefficient than the keyboards that were generated by the genetic algorithm, but still much more efficient than the QWERTY layout.
There's more. Listen, man, that there's more to this. You're telling me that there's extra ways of making this efficient. One of the things is that, like, okay, it makes for an efficient keyboard, of course, right? But why would we change it? Like, I think, to me personally, from my own experience, I think that the best thing to do is just keep the keyboard that we already have, the layout we already have, because I feel like you don't need more than just 100 words per minute. Like, honestly, like if you could type faster than 100 words per minute, I mean, good for you. But personally for me, I found that like typing beyond 100 words per minute, it's kind of useless. Like, at least for me. Yes, it's nice to type faster than that, but at the end of it all, like, what's the point of it, you know? Like, I feel very comfortable at around 101, 100, 109, 99, 106. Like, I'm comfortable with that, and I can get almost everything done. And by the way, a lot of these that are really low, it's because I highly suggest, if you guys want to learn your typing, I highly suggest this Monkey Type website. You can subtract, you can add, you can change everything that you want. If you want like extremely hard words, you can even change it. Like, let's say you want English 450K, they give you some of the hardest words that are hard to what do you call it, type out. As you can see, these are words that I will never even type, so it's a lot harder for me to when I get to these letters, I mean to these words, it's so much harder that I don't even type these out. So now when I'm typing, I have to actually think where the letters are at, because it's no longer using muscle memory. And believe it or not, a lot of this is like muscle memory. So if we go back to just regular English, like, it's so easy for me to just type it because I already know where it's gonna be at, what I have to type without even thinking about it. I can even talk to you guys while I do this. With the other one, I can't do that. I can't talk to you guys. I actually have to pay attention. I have to think about where the letters are at. So yeah, I highly recommend this website. And then if you want something a lot more challenging, which is why I usually score really low, I usually add numbers. Numbers are very difficult for me. Whenever I get to one, I usually have to like look at it and be like, where can that number be? I'll show you right now. So right here, I get here, I'm like 2, 1, 6, and I gotta, like, without even looking at the keyboard, and I have to like touch the J and then move up. I touch the 7. It's supposed to be 6. Numbers are hard for me. As you can see, I scored 34, but that's cool though. And then you can add punctuations as well, face up, like, you know, practice your commas. Oh crap. It really throws me off. Anyways, yeah. So that's the point. Highly recommend that website if you guys want to like practice the QWERTY keyboard layout.
Thought it would also be interesting to find the best keyboards for various different situations as well. For example, what if you don't use all 10 fingers to type and instead only use 2 fingers? What would the best keyboard be then? This situation would be very common when typing on a mobile device, or for people who haven't learned how to type with all 10 fingers yet.
You know, okay, I know how to type extremely fast and I know my words, right? Excuse me. Typing on a phone is so different from typing on a keyboard. Now, I'm gonna tell you, it really does make a difference. If you know how to type on a keyboard, you definitely know how to type on a, type on a smartphone, because you already know where the letters are at. You do have to think a little bit more, but for the most part, you already know where the letters are at, because even though you don't use the fingers, you know where to type because of the words that you've typed on the computer. So it allows me to type extremely fast on the phone. The only problem is that I make so many mistakes when it comes to typing. Dude, if it literally, people hate autocorrect, but if it wasn't for autocorrect, my messages would sound like hieroglyphics, or it would sound like Monkey was the one typing that message. You know, given enough time, I would probably type out Romeo and Juliet, because I mess up so much on that and on that keyboard. So thank God for autocorrect. But anyways, let's see what he has to say.
For this situation, we can run the genetic algorithm in the same way. We just need to measure the distances differently. In this case, I assume that the starting positions for the 2 fingers would be over the D and K keys. The total distance to type the dataset using 2 fingers would be 343,000 on a QWERTY keyboard. These are the layouts that were generated by the genetic algorithm. The main thing to notice here is that it groups the vowels together on one side and the commonly used consonants together on the other side of the keyboard. This is pretty intuitive, since the commonly used keys are placed closer to the starting positions of the 2 fingers and the less commonly used keys are placed further away. If I were to propose a keyboard design implementing this, it would probably look something like this. The next situation I wanted to test for was using 1 finger to type. I adjusted the distances and ran the...
This is for like all the the older generations, those like beyond, like, you know, adult, young adult years, like people beyond 40. This is how they type. They type with just using 1 finger.
The algorithm 3 times again. These were the keyboards that were generated. These results were actually slightly surprising to me. I would have expected that the most commonly used keys would be grouped in the center of the keyboard, but in all of the layouts, they were actually grouped slightly more to the left around the 4th key in the 2nd row. This doesn't seem super intuitive to me, and I'm not sure why the AI found this to be more optimal than having the commonly used keys in the center. Nevertheless, if I were to propose a keyboard layout implementing this finding, then it might look something like this.
That's interesting.
The last thing I wanted to test was how the keyboard would change if the content of the text was different. For example, if you were typing code in Java, you would need to use the semicolon key far more often than in standard English, since it appears at the end of every instruction. To test this, I switched the text dataset to 6,000 lines of Java code extracted from the GitHub Java corpus. I then ran the genetic algorithm again for the normal 10-finger keyboard, and this was the result. As expected, the semicolon key is now in a position closer to the home keys. One interesting observation is that C is now on the middle row instead of L. This could be because C appears more often due to Java keywords like package, interface, static, switch, case, and catch, which are all used frequently and contain the letter C. The RSTLNE keyboard layout might be the best for typing standard English using 10 fingers, but depending on how many fingers you use to type and the type of content you are typing, the most optimized keyboard layout can change significantly. If you're curious to try out the keywords created by the AI, I created a simple website at atomcodes.github.io, link in the description, where you can do typing tests using the different keyboards in this video. I put this together in about 1 day, so it might be kind of buggy or look weird on certain devices, but the general functionality should work.
QWERTY versus
Realistically, I don't expect anyone to actually change the way they type just based on this video. Learning to type can take a while to learn and be comfortable with. It's just not worth the effort for most people who are already familiar with the QWERTY layout to relearn where the keys are in a different layout.
Yeah, listen, I heard that it takes about a full year, to kind of get the average grasp, and that's just the average grasp of a new layout. Honestly, like I said, dude, like at this point, because the QWERTY layout is omnipresent in all of the world, even in Japan, they use Romanji to type. So they'll use like, you know, wa, like just use pure like vowels and then just the common consonants. In that they don't have like a keyboard where it has like all of the hiragana there. They have to type it out. There's some people who are extraordinarily fast with that, you know. It would make sense to have a different layout for them, but for the most part, the QWERTY keyboard, it does the job. I feel like you don't need to be typing more than 100 words per minute. Anything beyond that, I feel like it's just a plus. But it's fine. You're fine with this layout. I don't think you need to change it. But anyways,
even if it is significantly more efficient, the QWERTY keyboard has already stood the test of time for nearly 150 years, and it seems like it'll stay that way for at least 150 more. I do think it was a really interesting experiment though to see how the keyboard could be improved, and if anyone actually tries it, let me know how it goes in the comments. If you made it this far and enjoyed the video, then consider leaving a like and subscribing.
We gotta go try it out. Now obviously, like, I'm not gonna be able to type extraordinarily fast because this is a new layout, and the majority of the time a lot of these words you know, I don't have the memory for it. So the S-E-R, okay, so like I already want to type the D, which is right here in the middle. So where's the N? Oh, space? Still the same? Damn. I typed the K because that's where the I goes. Damn. I keep forgetting that the words aren't there. Let me see. Mention. Oops. Where's the L? Oh. Damn it. Wow. And all right, this is gonna be the last word, man. I am not getting these. Where's the G? Oh. Goment. Oh, I forgot the comma. Is that a comma? All right. That is probably 1 word per minute. And damn. I don't know how this would be, honestly. it's pretty interesting. There's definitely a difference that I felt. I felt like I could probably fall in love with this one, with this layout. Honestly, two fingered. Oh, I thought he had the QWERTY keyboard out there too to see what it would be like, but no. What an interesting experiment, dude. I'm not lying when I tell you that I would probably learn this keyboard if it did become standard. I'd probably take my time to learn it because I could feel the difference. Now, obviously, I would have to have more time with it, but the only thing is just the M. The M is still there. Boom, boom. I don't know why I had the M all the way back here though. Oh, that's right. Okay, so it's no longer the M. It's a J, and then the M is back here. Yeah, I don't know about this one. No, but I guess that's what the AI decided, but it's hard, man. Hang on. Let me I just need a look at that for the first time ever. All right, guys, so I guess that's pretty much it. That was pretty interesting, and yeah, I think that if it did become standard, I would definitely learn how to type on that layout. So anyways, let's see what I'm about to place. Oh, you know what? Whatever, 90 words per minute. Anyways, yeah, I think that's pretty much it, guys. If you guys want to learn how to type faster, Monkey Type, this is one of the websites I highly recommend. It has so many options. You could change it up. You could even go into the settings, and there's extra settings here that you could just like toggle with, play around with them, and it should make things a lot more interesting. So let me see. Yeah. You could change the difficulty by adding punctuation and numbers. You could even it'll even give you like little quotes right here. And then of course, if you want to like change the speed to a custom speed, let's say that you want to like have 100, you could pretty much keep up with you pretty much challenge yourself at 100, you know. So let's say that, for instance, you're a person who types at like 45 words per minute. You could like race yourself, you know, see. And then once you get better and you surpass your thing, you can change it up. Obviously, I practice more than 100, so I stay at 100, you know, and I just have to keep up with it. Yeah, so there you go. I type way faster than 100 words per minute, as you can see, so I don't need to show that off. But anyways, yeah, guys, yeah, good luck with that. This was such an interesting video, and yeah, I was happy I took part in it. I saw it like there was a what do you call it, a notification from the news app on the iPad, and that's how I found out about that. I wanted to check it out on my own to see what that layout looked like. But anyways, I hope you guys enjoyed it, man. Hopefully I made it entertaining, and yeah, you already know what's up, man. Go ahead and subscribe.